Hello and welcome. In the alkyl halides chapter that we have been doing for, I think this will be the 7th lecture, right?
Yes, sir.
So extensively discussing the mechanisms very thoroughly, particularly the elimination mechanisms, all varieties of elimination mechanisms, including the syn elimination, EI, internal, where there is a cyclic transition state where the two living groups will leave from the same side, syn, with a cyclic transition state, like Chugev reaction, like Cope reaction, and the pyrolysis of acetates. So we have done that. Also Hofmann elimination, in which case you get an exclusive or dominant Hofmann product, like the Hofmann exhaustive methylation. Or the point is the heating of quaternary ammonium hydroxide obtained from a 3-degree amine hydroxide, 3-degree amine, then 4-degree ammonium hydroxide. 3-degree amine, if you have a 1-degree amine, then you have to convert into 2-degree, then 3-degree, then 4-degree ammonium salt, then make its hydroxide, then heat it. You will get two things. One is a 3-degree amine and the other one is an alkene. And the major pair will be decided by Hofmann rule. That is, the least substituted alkene along with the corresponding amine will be the major pair of products formed. Let's take in several examples. Today, we shall be doing the remaining part of these things we have done. We have also analyzed the elimination versus substitution. In which conditions elimination product will dominate and which mechanism at that time will operate. And in which time the substitution will dominate and what is the mechanism. We have already done. So all the substitution reactions, SN reactions we have done. This has a name. Who can tell me what name this I told you?
Sir, Hofmann analysis.
Yes. I've told you that there is a name of alkyl halide. Keep this. And we have with the sodium sulfite, you get a sulfur nucleophile. Sulfur donor will take the lead of attacking, and you get sodium alkane sulfonate. You can add this another nucleophilic reagent which produces SN reaction. We have seen elimination reactions of different types. Yeah, you can write one point in alkyl halides which is taken to produce Grignard reagent. Rx plus magnesium in ether medium will give you RMGX. Also produce Gilman reagent. Rx with lithium and cuprous halide will give you dialkyl lithium cuprate, where there is a considerable carbanionic character, minus delta character in the alkyl group. Ultimately, it will attack as a nucleophile, R minus. So the use of Gilman reagent, anybody who can remind me where we have done the use of Gilman reagent in the second step? Rudrani?
Yes.
In which reaction we have used the Gilman reagent?
Sir, Korea House.
Precisely Corey-House synthesis. In the Corey-House synthesis of alkanes, we have used, first we have prepared the Gilman reagent by reacting the alkyl halide. This can be 1 degree, 2 degree, 3 degree with the lithium and cuprous halide. And this then Gilman reagent is allowed to react with the second alkyl halide. That should not be a 3 degree. 1 degree or 2 degree, so that one R couples with the other R dash to produce the desired alkane with the elimination of another residue RCU plus LIX. So this you know. Now physical properties you write at home. I think this file I have given. If not, I will be resending it. Okay? Have I given
Okay.
this?
No, sir.
Okay, I will send it. In the physical properties of alkyl halides, methyl chloride, methyl bromide, ethyl chloride, and chlorofluorocarbons called freons are gases. Others are either liquids and higher members are solids. Greater than, boiling point is greater than alkane, alkene, alkynes having comparable molecular mass due to its higher dipole moment. Polarity is more because the carbon halogen bond is polar and hence it is dipole moment is more. But among the halides, you have to look to the polarizability. More is the size, more is the van der Waals forces. These all are under the category of van der Waals forces. So Ri greater than RBr, RCl, RF. Boiling point decreases with increase in branching. That is the case with every kind of homologous series. When there is more branching, the area of contact will be less, so the van der Waals forces will be less, and hence the boiling point will be less. 1 degree will be the highest, then 3 degree will be the lowest. If branching increases from 1 degree to 2 degree to 3 degree, then the boiling point decreases among the isomeric haloalkanes. RBr and Ri, these are the two which develop color with a light due to photochemical reaction. They decompose to produce iodine and bromine respectively. And, then they produce color. Iodine and bromine, they are colored compounds, colored substances. Density increases because of the increase in the size, atomic mass. The density also increases from RCl to RBr to Ri. They are feebly soluble in water, more soluble in organic solvents like ethanol, acetone. The low solubility in water is due to the presence of strong hydrogen bonding in water, while a weak dipole-dipole attraction of the Keystone forces in alkyl halides. They do not match. And moreover, they carry the alkyl group which is non-polar. The carbon chlorine bond that is slightly polar, but the other alkyl group, ethyl, methyl, propyl, butyl, they are non-polar, so they don't like water. So they are feebly soluble, but slightly soluble in water. They are soluble in organic solvents due to presence of similar van der Waals forces, except ethanol, which has hydrogen bonding, but it has got a non-polar part, ethyl, that helps in dissolving alkyl halides, but has a non-polar ethyl part. Let us talk something about methylene chloride or dichloromethane, which is fondly called methylene chloride. It is used as a paint remover, a very good solvent for organic reaction, aerosol propellant, metal cleaning. Let me tell you what is aerosol propellant. You know, uh, if you spray something, even if you have a hanky spray or a perfume spray which you spray in your body, then that in fact carries a very small quantity of perfume. The large quantity is the solvent, which is not toxic at all to the skin, non toxic. That carries a small amount of perfume which is having high molecular mass, which is not volatile at all, but it is carried by a volatile solvent like methylene chloride. So most of the insecticides, those are applied to the agricultural purposes in fields to kill the bacteria and other microorganisms which act as a potential, you know, pests to the agricultural production. They need a spray of agricultural, drugs. So they are not simply sprayed. They are mixed with some solvent. They are called aerosol. They produce a um, gas solid or gas liquid colloidal system called aerosol, where the gas is the dispersion medium and either liquid, high molecular liquid, or solid as the dispersed phase. And they spray, and it is the volatile solvent which carries the non-volatile perfume or the drug, and that act as a aerosol propellant, propels. So the chlorofluorocarbons, which are also used as aerosol propellant, and the major component in the atmosphere which is sent, uh, and they are non-toxic, no doubt, but they go up, they rise up and up above the stratosphere where we live. They go to the troposphere where we live. They go to the stratosphere where ozone is there. So those chlorofluorocarbons and other aerosol propellants which are produced, used, applied in large amount in vast agricultural fields and other places, they go up and up, reach the stratosphere where ozone layer is there. They interact with ozone layer and destroys it, and produces a lot of holes in the ozone layer. That has become a major health issues, where the ultraviolet light is let loose and come to the earth in large concentration, I mean large amount, so that we get affected, the skin get affected. Welcome, Saminani. And in fact, in Australia, I visited last year, maybe no, year before last. I found that since it is close to the South Pole, and the maximum ozone layer depletion or holes will be found there above Australia, New Zealand, and those places near to the South Pole. There is a reason behind it. We are not going to discuss that. So there, every 2 kilometers or 1 kilometer, you'll find a skin center. Lot of people there, they catch skin cancer, and no one is found in the sun in the daytime. They are all found inside their cars, their vehicles, buses, and all that. They don't walk under sun. They walk only when sun sets, in the evenings, or in the early mornings. They walk. In the daytime, there is a scorching heat. They avoid. They don't go out because it carries a lot of ultraviolet rays to harm their skin. And therefore, I was talking about aerosol propellant. Samita, have you heard me explaining about aerosol propellant? Samida?
No, sir.
Okay. They are the solvents which are volatile. They are present in every kind of spray, including the perfume spray that we use in our bodies, because they carry the non-volatile materials. Maybe the perfume is not the liquid that is being hit. The spray which is in the form of vapor, they hit your body. They are not actual perfumes. They are solvents which have no odor, no, they are not toxic at all, but they carry small amount of perfume which are non-volatile. So similarly, the drugs, the insecticides which are applied to the agricultural field in large, the helicopter in vast fields in the west, they use the insecticides with aerosol, with a propellant which will propel, which will be used in helicopters to apply in vast fields. So these carry chlorofluorocarbons as the solvent propellant. They will not react with anything. They are non-toxic. They will rise after the original heavy insecticides fall into the fields under gravity. These volatile components which are now converted to vapor will not condense. They are in the liquid form by applying pressure. Their critical temperatures are higher than room temperature, so they have been liquefied by applying pressure. When they let loose, they remain in the gaseous form. They are gases. I have already told you, Samita, you were not there. Methyl chloride, methyl bromide, and ethyl chloride. These are the three alkyl halides, and all chlorofluorocarbons, those are called CFCs, they are gases. Others are liquids or solids. They are harmful to the nervous system, skin, and eye. Of course, chlorofluorocarbons are non-toxic, but methylene chloride, about which we are studying, they are harmful to nervous system, skin, and eye. Similarly, chloroform, which is also a solvent for fats, alkaloids, iodine, used for the production of freons. We'll talk about how freons or chlorofluorocarbons are prepared, used as an anesthetic. Earlier, when surgery was being performed, they were giving a chloroform soaked cotton to inhale, and the patient goes to unconsciousness after inhaling chloroform, which is a volatile, and it will come out as vapor and goes to. So, used as anesthetic, harms the liver due to formation of carbonyl chloride or phosgene in kidneys. So, this is an important reaction where chloroform, in presence of light, reacts with oxygen, is oxidized to carbonyl chloride and HCl. Today, Samita, we are finishing the alkyl halides, and from next class, we'll be taking haloarenes, chlorobenzene. That is a short chapter. Carbon tetrachloride is also the same propellant for aerosols, preparation of freons, and also as a solvent in organic reactions. Harmful effects are on nerve cells, heart, eye, helps in killing ozone. Now, let me tell you what are freons. Chlorofluorocarbons or freons. These are organic compounds that contain only carbon, chlorine, and fluorine. Not in, and hydrogen, of course, produced as volatile derivatives of methane, ethane, and propane. As volatile derivatives of methane, ethane, propane. They are at normal pressure, they are gases, they are vapors, but they have been liquefied by applying pressure, like ammonia, like other gases. They're used as refrigerants and aerosol propellants. Stable, non-reactive, non-toxic, non-corrosive, and easily liquefiable by applying pressure. It decreases ozone in stratosphere. Now see how we will This is important for your examination. How we can understand the Freon number, the numbering system. Freon 1 2, Freon 2 2, Freon 1 2, 2 7, 2 seventh of 2 3. So this, the rightmost number, there are three numbers actually. The rightmost number is the fluorine number of fluorine present in that molecule of chlorofluorocarbons. Left to that is the number of carbon atoms minus 1. Means there will be nothing, no number for chlorofluorocarbons containing one carbon. That means produced from methane. They will carry only two digits. The middle digit will be missing. Carbon number minus 1. Then rest is chlorine atoms. Sorry. The left to that, I'm so sorry. Left to that is the number of hydrogen plus 1. Number of hydrogen plus 1. And the leftmost, which I unfortunately told otherwise, the leftmost which is missing out for methane based chlorofluorocarbons is the carbon number minus 1. So there are only two digits in methane based freon. So if we say freon 1 1, it means it contains one fluorine, and since there is no hydrogen, no, 0 plus 1 is 1. This is the hydrogen plus 1 number, and the leftmost is the carbon minus 1, that is 0. So 0 is not written. Carbon is only 1, 1 minus 1, 0, 0 is not written. So freon 1 1 means it is trichlorofluoromethane. And 1 2 means there are two fluorine atoms, and there is only, so there is no hydrogen, so hydrogen plus 1 is 1. So this 1 is hydrogen plus 1. And carbon minus 1 is 0, 0 is not written. So in this way, you can say freon 2 1, freon, even 1 for 1. When it is a ethane based or a propane based freon, then you will get two digits. Freon 1 for 1 is this. You automatically, you just first write 1 means fluorine 1. See the last digit. 1 means there will be 1 fluorine here. And this 4 means this is hydrogen plus 1. That means there are 3 hydrogen atoms. So write CH3. And how many carbon? So 1 means 1 plus 1, 2. So 2 carbon atoms, 3 hydrogen atoms, and 1 fluorine. And the remaining chlorine, you count, take the formula, they are saturated compounds, and see how many chlorine atoms are required to saturate. You can get the number of chlorine atoms. So once the freon number is given to you, this is there in your CBSE, I mean NCERT book, as I guess. You can just check. You can get the formula of the freon, you can easily get. So this is a propane based preon having 3 carbon atoms. So 5 means there are 5 chlorine atoms. F2 here, F2 here, F here. And 2 means hydrogen will be only 1, because hydrogen plus 1. So you have to subtract 1 to get the number of hydrogen atom. And here you have to, 2 means you have to add 1 to get the real number of carbon atoms. Not this number will indicate number of carbon atoms. This plus 1 is the number of carbon atoms. And this minus 1 will give you the number of hydrogen atoms. And this is the number of fluorine atoms. And the rest, chlorine. You can attach. It is difficult to know the exact formula in this case, because out of 5, maybe 3 of them will be attached to 1 carbon. But you can write the formula. C3, F5, H, and Cl2. There will be only 2 chlorine required. There is another method which is not in your that when you add to the previous number, this is 113, 141, 21, you add 90 to the previous number that we have done according to the principle that we studied. it will give the number in the order. First number will be the number of carbon atoms. Then, no, it is not minus, followed by number of hydrogen atoms, then followed by fluorine, then rest you can count how many chlorine atoms will be there. For example, Freon 113, you add 90, it will be 203. That means 2 will be the number of carbon atoms. Then 0 will be the number of hydrogen atoms. Then the third one is the number of fluorine atoms. And the rest you can calculate how many chlorine atoms would be there. So this is another one. But it's not required. Once you get this, you know the number of carbon atoms, everything. So this is another way. And then let us know how freons are prepared. Simple freons, freon 1, 2. 1, 2 means, and there will be 1 minus 1, no hydrogen, 2 fluorine, and nothing is there means 0. That means 1 carbon. It is methane based CFC, Cl2F2C. That is prepared from carbon tetrachloride with HF with antimony pentachloride or antimony 5 chloride as catalyst. You can also get which is called freon 22, or sometimes it is called R22. That is with HF, chloroform and HF. This R22 is a very important compound, because that on dimerization the hydrogen and hydrogen they go out as hydrogen gas, and there is a connection with a double bond. So you get CF2 double bond CF2. This is tetrafluoroethylene, which is an important monomer for the polymer polytetrafluoroethylene. When this is polymerized, double bond pi bond breaks and dash dash on either side, and then a parenthesis, then subscript N, that will be polytetrafluoroethylene. That is also called Teflon, which is a non-sticky plastic. And most of the kitchenwares, the handles and all that, they carry Teflon, which will not stick oil and water. So that has a very, very versatile application. These halo compounds, according to your NCRT, because I have not left any materials, because the NCRT is required for the NEET level examination and the first JE mains. But advanced, there is no restriction. They can ask anything, and because this is a relative ranking, so you can't challenge. Some of the important compounds of halo compounds are chloramphenicol, which is used as an antibiotic for typhoid, is a very old and outdated drug. Chloramphenicol. Thyroxine, that is present always in our body, is a hormone containing iodine. Deficiency produces disease called goiter. Chloroquine is a drug for malaria. Halothane is an anesthetic for surgery. So this is all about our haloalkanes program, but we will take another 10 minutes to start interesting aspect of chlorobenzene, haloarenes. So let me bring you the, without wasting time, we now see, Samidha, haloarenes is nothing but chlorobenzene. The most important haloarene is chlorobenzene, from which many other compounds are prepared. Bromobenzene can be prepared, iodobenzene can be prepared, fluorobenzene can be prepared. But out of all, chlorobenzene has versatile applications that we will study, but we will take X representing any halogen. So here we study another mechanism that is called electrophilic substitution. We had studied how many mechanisms? Just count. In alkanes chapter, we studied free radical substitution, only one. In alkene chapter, we studied electrophilic addition, free radical addition, and we left substitution and elimination, although they were required for study, but the detailed mechanisms we had reserved or deferred for haloalkanes. So three mechanisms we had done so far in alkynes and alkanes. What? Free radical substitution, then free radical addition in alkenes and alkynes, then electrophilic addition. We have not yet studied nucleophilic addition, where in the rate determining step you have a nucleophile to attack. In alkenes, which are almost nonpolar, they are rather nucleophiles because of the pi bond. They love the electrophile to be attacked onto them. So electrophilic addition, I've seen. Then in haloalkanes, we studied the SN mechanisms in details, SN1, SN2, SNI, SN1 dash, SN2 dash, SNI dash, SN and elimination in detail. E1, E2, E1, CB, Sin, Hopman, all this we have studied. So we have studied 5 mechanisms in details. Now in halobenzene we'll be studying electrophilic substitution. Nucleophilic substitution we have done. Another nucleophilic substitution we'll be doing, which is named as acyl substitution. Nucleophilic, not simply nucleophilic substitution. Nucleophilic substitution will always mean SN, SN1, SN2. Those who had not attended, like Prachi, and maybe in some class Samidha, I would definitely urge upon you to watch the video. Have you watched all the videos, Samidha?
Yes, sir.
Yes. Prachi, you also watch if you have not, to get the details of the mechanisms. Are you NEET-minded or IIT-minded, Prachi?
Sir, neat.
Okay. No worries. But for getting a good position, so as to get a seat in AIMS, the major AIMS, Delhi and other major AIMS, it is needed that you prepare like an IIT aspirant so that you get a good position in the NEET list and you get a seat in a better medical college. Okay. Now see here, we will study that. Benzene, we have done in our no. We have done, I don't remember, we had done in our GCOC program. We have only known the minus M plus M effect and how have we done about the orientation and reactivity, which group is a OP director and an activator for the then we must have done electrophilic substitution. Yes?
Yes, sir.
We'll be doing it again. We have done electrophilic substitution. Now I will be adding 6th, but there will be repetition. If we have not done the mechanism, but we only know that the plus M groups or plus R groups, as well as plus I groups like methyl, ethyl and all that, they are orthopara directors for the second electrophile to come. Both in ortho and para, you get a mixture of ortho disubstituted product and para. And which one is dominating will be dependent on many factors, like a steric effect. If the already existing group is bulky, then para will be the major product. If it is not that bulky, then ortho is the major product, because ortho's probability factor is 2 times more than para. There are 2 ortho positions, but 1 para position. But if it is A group like acetoxy O COCH3, like bromine, like iodine, bulky group like O dot butyl. So if there are a sulfonic acid group, in that case, we will find the ortho product very, very minor or almost absent. But those who are minus M groups or minus R, electron withdrawing groups, like nitro, like sulfonic acid, like carboxylic acid, like cyanide, cyano, all these they do not carry a lone pair, rather they have a pi bond as well as an electronegative nitrogen, sulfur, and all electronegative atoms like oxygen, so that they withdraw electron density from the ring by resonance, by conjugation. So, their orthopara positions are electron deficient. They carry plus delta charge. So, relatively, the meta position is more electron rich, so that the electrophile will attack the meta position. So, they are meta directors. And one set of groups, they have opposite characters. While reactivity, yeah, I forgot to tell you, all meta directors are deactivators. They slow down the reaction electrophilic substitution vis-a-vis benzene. And all, not all, okay, all but, I reserve for you to answer, all but some groups, plus M or plus R groups or plus I groups. They are OP directors and activators. They enhance the rate of reaction. But which groups are OP directors but deactivators? Saminani. First, I ask this question to Samida. Which groups, if you don't remember, then I would definitely will want to revise. If Samida says or anybody says, then I would be uh, planning to revise this portion again. Yes. Do you remember, Samida? No answer. Are you able to hear me?
Yes, sir.
Now turn. This is the Rudrani's turn.
Sir, halogens.
Yes, chlorofluorobromo. The halo group, halogens कौन कହୁଛ mo? Oh, I'm
Yes,
sorry.
sir. Hello.
Halo group. Halo group. Dash Cl, dash Br, dash I. These are, though electronegative and has minus I, electron withdrawing character, they will deactivate the electrophilic substitution reaction. But they will send the new electrophile to the orthopara position. They are OP directors but deactivators. So here is the case where we are studying such halobenzene, where the chlorobromoiodo group, they will further substitute, the second electrophile will come to the orthopara position, but it will slow down vis-a-vis benzene. Did you recollect, Miss Samida?
Yes, sir.
Are you dozing? No, sir.
No, sir.
And Miss Prachi, are you able to understand what we are doing?
Yes, sir.
That's good. Feel free, Prachi, to take my help, because your grandpa is so close to me that you can, uh, whether somebody is close to me or not, that is a सोने पे सुहागा. लेकिन my interest is to help those who need my help. And particularly so when I am in the same place where you are staying. It's my, duty to help you. So feel free. You guys are very, very busy. I know you hardly get a free time to, ask your doubts or to, yeah, Okay, but your mom told that yes, we were planning to go, and your grandpa told you were planning to go to your house with your student to meet you. Then I said you could have invited me. Your mom gave us, we were two, so many biscuits, and don't say biscuit. The pronunciation is not biscuit, biscuit. Remember, your mom gave so many biscuits and maybe other things I don't remember to eat. And then tea came, a super hot and tasty tea came, and we sipped while chatting with her grandpa. Okay. Next time when you are there, I have asked to invite me so that I will be with you for 2 minutes, chat with you. Okay. Samita, do you need these things to be repeated and revised? Feel free.
Yes, sir.
Okay. Okay, I will do that. Um, but before that, let me first finish the chemistry part, which is very simple. The benzene, when subjected to, this is one electrophilic. Let me do this. I will be taking, this is 45. No, I'll be leaving today early because I have a very important work to do. You remember, I have left you for some time and then returned back, which I won't do because after that I have some work. Therefore, I will leave you premature, and we will discuss little longer on. Today is Tuesday. On Thursday, we'll be sitting a little more time, maybe for 2 hours, maybe for 1.5 hours, to finish haloalkanes and sorry haloarenes, and plan for the alcohols, phenols, and ethers, right? But in coming Sunday, those who are interested, uh, appear the test both on electrochemistry and kinetics. I have to mix, I mean, add them, blend them together to have at least 40 questions, and I'll give you 2 hours time, 20 or maybe 45 questions, 25. Both are kinetics is little less bulkier than electrochemistry because electrochemistry has three parts: the conductance, conductivity part, the electrolysis part, and the EMF part. They are three different concepts. Although the conductivity can be correlated with electrolysis, when there is a conductance going on, conductivity also can be also correlated with EMF, because the ions get transported from one place to the other. So that is conductivity. Whether it is performing, whether it is a part of electrolysis and a non-spontaneous reaction happening with the application of a DC power, or it is producing a DC power, a spontaneous reaction, doesn't matter. But inside the electrolyte, what is going on, the ions are moving, how they are moving, what is their conductivity, molar conductivity, and the related things, specific conductivity, and and the most important is limiting molar conductivity, lambda naught. Have you seen, Samita, the interesting question that was said in 2023 or 2022 main IIT question, which was raised by Rudrani? Have you seen that? I discussed in the last class.
Yes, sir.
That is simply a derivation. Is Since I didn't tell about a possibility of a linear graph for weak acids, because I have shown for some concentration even the weak acids show linear region, but beyond that concentration, or above that dilution, then it turns very drastically, giving a curvature, I mean a curve. But up to certain concentration, decrease in concentration, you will find the increase in molar conductivity is linear. Okay, I close today's class because once I enter into the mechanism and the related revision things, which I will do, I feel like I will be doing for at least 15 minutes, so that you will be recapitulating what we did in our GCOC program. So see you on Thursday for a longer session. Bye bye. Sui podo,
Thank you, sir.
sui podo, sui podo, sui.
Pranam, sir.
Pranam, sui podo re dhanamali. Pranam.